Because ions have differing KSP values, we can actually separate one ion from another ion by adding a precipitating reagent. For example, what is the order of precipitation when iodide is added to a solution containing silver ion, copper ion, and lead-2 ion? We have KSP values for each of the precipitates that can form. This is the KSP value for lead iodide. This is the KSP value for copper iodide. We also have bismuth reacting with iodide, and here's its KSP value, and lead-2 reacting with iodide, and we have its KSP value. So we have several ions in solution, all at 1 molar, and we're going to add a solution containing iodide. In order to determine the order in which these cations precipitate with the addition of the precipitating reagent containing iodide, we need to solve for the iodide concentration at which saturation occurs, or the iodide concentration at which precipitation begins, which these concentrations are the same. We can do this using the KSP expressions for each of the possible precipitates that can form. In the case of silver, we have KSP being equal to silver concentration multiplied by iodide concentration, recognizing that the formula for silver iodide is just AgI. So the iodide concentration at which precipitation begins will be equal to KSP divided by the silver concentration, which is 1 molar. If we do the same thing for each of the other cations, we can determine the iodide concentration for each of them to begin to precipitate when saturation is reached. You'll see with bismuth, the iodide concentration requires us to take the cube root, KSP divided by the initial bismuth concentration, which is 1 molar. And in the case of lead-2 iodide, we need to take the square root of KSP over the 1 molar lead concentration. Now, looking at the iodide concentration needed for saturation to be reached or for precipitation to begin, you can see that the silver requires the smallest iodide concentration to begin precipitation. So the addition of iodide will cause silver to precipitate first. It's possible that we could add enough iodide to precipitate almost all of the silver out of solution and then filter the solution to get rid of the silver iodide solid, and then continue to add iodide up to 1.0 times 10 to the negative 12 molar, and then copper would begin to precipitate as copper iodide. After copper iodide has completely precipitated, then we could filter it out, and you see that we are separating the ions from each other. And then add a little bit more iodide to increase the concentration to 9.3 times 10 to the negative 7 molar, and so on. So the order of precipitation then is going to be silver first, copper, bismuth, and then lead. It turns out if the concentration is different, we could actually have a different order of precipitation. So the point here is the order of precipitation is a function of not just the KSP values, but also the initial concentrations of the cations.